Picture a wind turbine. You are already seeing it, right? A massive white pole, three giant blades slicing through the sky, planted out in some empty field or way out at sea where nobody has to look at it. Now forget that image completely, because a company out of Houston, Texas just proved you never needed any of it. No pole, no blades, no spinning. And what they built instead is sitting on rooftops right now, silently pulling electricity out of the air while looking like nothing more than a strange metal box bolted to the edge of a building. Once you understand how this thing actually works, you are going to start looking at every flat gray warehouse roof you drive past for the rest of your life. The company is called Aeromine Technologies, and it came out of the University of Houston, built on decades of research from a founder who spent his entire career designing utility-scale wind turbines, the giant kind, before deciding that model was never going to work anywhere near a city or a building. Too much space needed, too much noise, too dangerous for birds, physically impossible to bolt onto a rooftop. So instead of trying to make the traditional turbine smaller, Aeromine asked a completely different question. What if a wind turbine did not need to spin at all? What if you could steal the exact trick that keeps a race car glued to the track at 200 miles an hour and flip it upside down to rip energy out of the air instead of pushing a car down onto it? Because that is essentially what an Aeromine unit is. It looks like a tank sitting on your roof, flanked by two completely motionless airfoils, shaped almost exactly like an upside-down race car wing. When wind hits those airfoils, it creates a pocket of low pressure between them, and air, just like water, always rushes to fill a vacuum. So that low pressure zone starts sucking air through an internal pipe, past a small propeller hidden safely inside the unit, and that hidden propeller spinning quietly out of sight is what actually generates the electricity. The wind itself never touches a blade. Nothing on the outside moves. You are looking at a completely stationary object on a rooftop that is somehow generating power out of thin air, and there is genuinely nothing else on the market that works quite like it. Here's where it gets clever, and I need you to actually sit with this for a second, because it flips the entire wind energy problem on its head. A traditional turbine needs the wind hitting it directly, and it needs a decent amount of it, usually at least 9 miles an hour before the blades even bother turning. Anything less, and the whole thing just sits there, dead weight on a pole, doing nothing. Aeromine starts generating power at wind speeds as low as 5 miles an hour, roughly the speed of a breeze that would barely move a flag. Its actual cut in speed sits around 2.5 meters per second. That is a whisper of wind most people would not even notice on their skin, and Aeromine is already pulling usable energy out of it. Think about what that means for a city rooftop, where the wind rarely blows hard and steady the way it does out at sea. A traditional turbine sits there useless most days. Aeromine keeps working, and unlike a bladed turbine spinning wildly and dangerously in a storm, this whole system is built like it belongs to the building, rather than sitting on top of it, fighting the elements. These units are rated to survive hurricane force, winds up to 120 miles an hour, with reinforced versions built to take a beating up to 158 miles an hour. Each one weighs a little over 1,000 pounds, and because the only moving part is a small protected propeller tucked deep inside a sealed duct, rather than a giant exposed blade getting hammered by weather every single day, the company claims these things could realistically run for as long as the building itself stands. No gearbox grinding itself to pieces, no bearing seizing up in the cold, no ice forming on an exposed blade and throwing chunks of frozen debris off the roof. Just a sealed, boring, reliable box quietly doing its job where you cannot even see it. Now let us talk numbers, because this is exactly where Aeromine stops sounding like a science experiment and starts sounding like a serious business decision. One single unit produces about 5 kilowatts of power, which Aeromine says is roughly equivalent to what you would get from 16 solar panels. And here is the number that should actually stop you in your tracks. It does that while occupying only 10% of the rooftop space a solar array of the same output would need. 10%. That means a business could line the edge of its roof with these units and still have almost the entire roof left over for solar panels, batteries, HVAC equipment, whatever it wants. Independent testing from Sandia National Laboratories and Texas Tech University backed up the claim that unit for unit, these things can outperform solar on a straight cost basis, with Aeromine putting the number at up to 50% more energy generated per dollar spent, 50% more output for the same money on a fraction of the space. That is the kind of number that makes a facilities manager sit up in a budget meeting. And this is not a company selling a dream on a slick website. BASF ran a real pilot installation at its manufacturing plant in Wyandotte, Michigan, testing the system in actual working industrial conditions. BMW installed a row of these units on its mini factory in Oxford, England, working alongside the plant's existing solar panels, the first project of its kind in the entire UK. And in 2024, Aeromine pulled in $9 million in Series A funding specifically to scale up manufacturing and get more of these units onto more rooftops faster. This is not a lab prototype gathering dust in a warehouse somewhere. It is being tested and installed on real buildings backed by real automakers and real chemical manufacturers right now while you are watching this video. But let me give you the honest picture here, because this is not a magic box you are bolting onto your house next weekend. Aeromine is built for big, flat, commercial rooftops, warehouses, apartment complexes, data centers, factories, buildings with acres of flat roof, and a wind direction that stays fairly consistent throughout the year. It will not work on a sloped residential roof. And unlike a weather vane that swings around to catch wind from any direction, these units are fixed in place, facing whichever direction the wind blows most often at that specific site. Aeromine actually studies each building's local wind data before recommending how many units to install and exactly how to orient them. Get that placement wrong, and you are leaving real performance sitting on the table. Get it right, and you have a silent, motionless, completely bird-safe power plant bolted to the edge of your roof, working around the clock while your solar panels handle the daytime sun and shut off the second it gets dark. And that contrast is worth sitting with for a second, because it tells you exactly where this technology is actually headed and where it is not. Aeromine was built to solve one very specific, very large-scale problem, giving massive commercial buildings a way to generate serious power without sacrificing the rooftop space solar desperately needs. It is not coming for your house. It is coming for the flat gray roof of every warehouse and distribution center in the country, the kind of buildings normal people drive past every day without ever thinking about, sitting there quietly wasting an enormous amount of usable wind while doing absolutely nothing with it. It is also worth understanding just how different this approach is from other bladeless wind concepts floating around right now. Some companies out there are chasing turbulence head-on, building small independent systems that flutter and twitch to react instantly to chaotic gusty wind bouncing around at ground level in every direction at once. Aeromine is not playing that game at all. It is not trying to catch every unpredictable gust from every angle. It is doing something closer to precision engineering built for one dominant wind direction, one specific rooftop geometry, and one very particular customer, the commercial building owner trying to squeeze every last watt out of a limited amount of roof real estate. Different problem, different building, different customer, but the same underlying instinct running through this entire new wave of wind technology, which is that the era of giant spinning blades might not be the only way or even the smartest way to pull power out of the air surrounding us every single day. And if Aeromine keeps landing partnerships with names like BMW and BASF, and keeps proving those numbers out on real rooftops instead of just in a lab somewhere, that wasted wind sitting on top of every warehouse in the country is not going to stay wasted for very much longer.